Hi and welcome to this video on large decelerations. There is more content, quizzes and past papers on the website, which is www.elevise.co.uk. So let's get started. Large decelerations of objects can result in a great force being exerted on the object or the individual that's inside the object. For example, in a car crash, the car decelerates very quickly. This exerts a great force on the individuals inside the car, and this can cause very serious injuries. We are able to work out the force that is exerted onto an individual during a car crash by using Newton's second law. Newton's second law states that force equals mass times acceleration. Let's now have an example, and let's suppose that a car and its occupants has a mass of 1,000 kilograms. The car is travelling at 10 meters per second and then it crashes into a lamppost. It takes the car 0.2 seconds to stop. What is the force that is exerted onto the passengers? To work out the force, we're going to be using Newton's second law, which is force equals mass times acceleration. From all the information in the question, we can work out what the acceleration rate of the car is. And actually, we're going to get a value for deceleration because the car was travelling at 10 meters per second and then crashes into a lamppost and comes to rest. To work out acceleration, we're going to be using the following formula, which is v minus u, and then we divide that by t. V is the final velocity and u is the initial velocity. T at the bottom of this equation is time, and this is the time taken for the acceleration or deceleration to occur. In the question, we're told that the car's final velocity is 0, and this is because it has hit a lamppost, and we are told that its initial velocity is 10 meters per second. So we do 0 minus 10, and this gives us a value of minus 10. And then we divide by the time period taken for the acceleration or deceleration to occur, which is 0.2. So we do minus 10 divided by 0.2, and this gives us a value for acceleration of minus 50 meters per second squared. This is a negative figure, and this means that the car is decelerating, it's slowing down. As we have the acceleration rate of the car, we are now able to work out the force that is acting upon the car's occupants. We do this by using Newton's second law, which is force equals mass times acceleration. The question told us that the mass of the car and its occupants was 1,000 kg, and the acceleration rate, which we've just worked out, is minus 50 meters per second squared. Therefore, we do 1,000 times minus 50, and this gives us a force of minus 50,000 newtons. The magnitude of this force is 50,000 newtons. We just take the positive, and this is a very large force. This force may cause serious injuries to the occupants of the car, and it may even result in the individuals dying. Cars have many safety features to decrease the force that is exerted onto the occupants. All of the safety features are essentially designed to increase the collision time. This decreases the deceleration and therefore decreases the force that is exerted onto the passengers. These lower forces means that there's a lower chance of serious injuries for the occupants of the car. One safety feature that cars have are crumple zones. These are located at the front and the back of the car. During an impact, these sections of the car will crumple, and they allow the impact time to increase. This decreases the deceleration and also the force that is produced by the collision. A lower force being produced by the collision then means that there's likely to be less damage on the occupants. Another safety feature that cars have are seatbelts. These stretch slightly during an impact, which increases the time taken for the wearer to stop. This causes the force that is exerted onto the chest of an individual wearing a seatbelt to be reduced. A lower force that is exerted onto the chest of an individual means that there's less chance of internal bleeding or organ damage. The final safety feature that we're going to look at is airbags. These explode during an accident and they increase the time that it takes for the occupant to stop. Airbags also prevent the occupants from hitting hard surfaces such as the steering wheel, dashboard, or the seat in front of you. All of these safety features are designed to decrease the force that is exerted onto the occupants of the car. This is because very large forces are extremely dangerous, as they can result in injuries and sometimes even death. So this brings us to the end of this video. For more content, quizzes and past papers, go onto the website, which is www.elevise.co.uk.